Rational equations. Okay, our objective in this video lecture, we want to solve rational equations, and we're going to define what that is, both algebraically and graphically. Okay, so let's recall some of the things we already know coming into this. We know what the least common multiple is. Also, it's sometimes abbreviated LCM. The least common multiple is the smallest positive number that two or more numbers divide into or go into evenly. And we also know from a previous video lecture how to solve a linear equation. Solving a linear equation has us doing the steps simplify, separate, solve, and of course check. So now, what's a rational equation? A rational equation is an equation that contains a rational expression. Now, my mom always talked about you should never have part of the word in the definition. So this leads us to ask, well, okay, that doesn't help me. What's a rational expression? A rational expression is a fraction, okay, or the root word here is ratio, so it's a fraction or a ratio, in which the numerator and or the denominator are polynomials. So a rational equation contains fractions or a fraction in which the numerator and or the denominator are polynomials. So let's take a look at some examples. Here are two examples of rational expressions. 3 over x plus 1 is a rational expression. 2x over 5 is a rational expression. And here's a rational equation. X minus 5 over x minus 4 is equal to 3 over x plus 2. An equation that contains at least one. This one contains two rational expressions. All right, another word for us we're going to be looking at a lot in the future in upcoming videos. What is the domain of a variable? The domain of a variable is the set of all values that the variable may assume, that the variable may take on. So here's an example. In the rational expression 5 over x minus 2, the variable x can be any value except 2, because we know that when we have a fraction, we cannot have a 0 in the denominator. So we can put anything we want in for x. X can take on any value, except it cannot take on the value 2. And so the domain, and this is called set notation with these curly brackets, the domain is the set of all x's. Here's the set. The set is the curly bracket of all x's, such that, this vertical line means such that, x does not equal 2. So the domain is any x as long as x does not equal 2. All right, so how do we solve one of these rational expressions algebraically? Well, we're going to start off by noting the domain. Because we're dealing with fractions, we need to be aware of if there's a chance that the denominator is 0. So we need to be aware of the domain and 0 denominators. And then we're going to find the lowest common multiple of the denominators, which is also known as the lowest common denominator. We're going to multiply both sides by the lowest common denominator because that will get rid of our fractions for us. And then we're going to have a linear equation, which we know we simplify, separate, solve, and check the resulting linear equation. We should have a linear equation at this point. So example 1 here. Let's solve 3x over 2 equals 8x over 5 minus 4. And let's look at our domain. Is there anything that's going to, these are fractions, is there anything that's going to result in a 0 denominator? Well, no. The denominators are 2, 5, and 1. So those are what they are. They're not going to change based upon what x is. So our domain is going to be the set of all x's such that x is the subset of all real numbers. X can be anything in this case. There's no restriction on our domain. Okay, now find the lowest common denominator. Okay, my denominators are 2, 5, and 1. Okay, what is the lowest common denominator? What is the smallest number that each of these goes into evenly? The lowest common denominator would be 10. Okay, so I'm going to multiply both sides of these by 10 to get rid of the fractions. So I'm going to recopy the equation to show you what I'm up to. Okay, I'm going to multiply this side by 10, and I'm going to multiply this side by 10. Multiply both sides of the equation by the lowest common denominator. I'm going to write it, this is a fraction, so I'm going to write 10 as a fraction to multiply it. So it'll look like this. Again, I haven't done any math, I'm just indicating I'm going to multiply the left side by 10, and since the left side is a fraction, I'm going to write 10 as a fraction. Okay, on the right side, I need to multiply each term by 10. This first term is a fraction, so I'll write 10 as a fraction. The second term is just a whole number, so I'll write 10 as a whole number. Okay, multiply everything on both sides by 10. Well, this is kind of nice. There's a common factor of 2, so the left side is 15. X. Okay, there's a common factor of 5. So the right side, is a 16x minus 40. Okay, so now I've multiplied both sides by the lowest common denominator, and I'm going to solve. Well, I can't simplify. Left side as simple as it gets. Right side. Let's separate. Well, I only have the x term is on the left, so I might as well move I normally like to keep it positive, but that's 2 moves. Let's just make 1 move, and let's keep track of that minus sign. So this is a negative x is equal to negative 40. So now we solve, which means, of course, x is equal to 40. Divide both sides by negative 1. All right, let's check our answer. Okay, so check our answer. We want to put 40 into the original equation. So the question is 3 times 40 over 2 equal to, that's a question, 8 times 40 over 5 minus 4. Well, let's see here. This is 120 over 2 is 60, I think. This is 64 minus 4. Again, it's still the question, and indeed, I check, my work checks out when I do my check. So there's how you solve a rational equation algebraically. Let's do it graphically. Okay, so here is our equation. Okay, so graphically, we know we've seen this before. We have an equation, so let's just set y1 equal to the left side. y1 equals 3x over 2. And let's set y2 equal to the right side. The right side is 8x over 5 minus 4. And let's do our calc intersect. And let's see if they intersect at 40. Okay, so I'm going to slide this up. We know we want the answer to be. We want the answer to be 40, which I left up there for you. Let's take a look. Okay, I think I got that in there for you. Okay, let's do here. So y1, open my calculator, excuse me, turn it on. y1, I'm going to use my fraction bar. Helps me keep things straight. 3x over 2 is y1. If you want to graph that, it looks like probably a line. There it is, 3x, 3 halves of an x. There's 3x over 2. Okay, we want y2 to be 8x over 5 minus 4. So again, I'll make use of that fraction bar. 8x divided by 5 minus 4. And let's graph. Well, oh, here it comes. It looks like it's getting closer, but it's out of my screen. It appears to be getting closer and closer, but it's out of my screen. Well, I think the answer is 40. So I need to go to the left, to the right quite a bit. Let's go from my window from -10 to 50. And let's count by tens. And then I probably need to go up a lot. So let's go from -10 to 70. And let's also count by tens. And now let's graph. There's equation 1, 3x over 2. Here comes equation 2, 8x over 5 minus 4. Yep, they're intersecting. It's coming in very slowly, but they're definitely intersecting. There are two lines intersecting somewhere around here. Well, our calculator will tell us. Let's go to Calc 5 intersect. I like to go kind of close to where I think it is. There's the blue. There's the second curve is the red. Take a guess, please. Press enter. And sure enough, they intersect when x is equal to 40 and y is equal to 60. So I can look here, and I came up when x is equal to 40, and the result was 60 right here. So I got it graphically as well. Okay, let's take a look at a couple more examples using this solving rational equations. So here's one. Okay, solve 1 over 3x plus 5 over x minus 2 over x is equal to 0. Again, we're dealing with fractions, so we first want to note, is there any chance the fraction can be 0? Okay, is there any chance? We don't want a 0, and the fraction's denominator can be 0. We don't want the denominator to be 0 because that's not going to work. Well, if x is 0, 3 times 0 is 0, and that makes a 0 denominator, and obviously just 0 is 0. So x can be anything but 0. Okay, anything you want, 1, 2, a half, -5, etc. The only value for x that results in a 0 denominator in both of these cases, as it turns out, is 0. So our domain, the set of, is these curly brackets, all x's, such that, which is what the line stands for, x cannot be equal to 0, or x is not equal to 0. So we've noted our domain. If we have an x, if we have 0 comes out, we know it's not an answer. Let's solve it. Okay, let's see here. What are my denominators? My denominators are, I have a 3x, I have a 6, and I have an x. Okay, what's the lowest common denominator? Well, how about 6 times x? 3x goes into 6x twice, 6 goes into 6x x times, and x goes into 6x 6 times. So that's my lowest common denominator. So I'm going to write this out. And I'm going to multiply both sides by 6x. So this side times 6x, and this side times 6x. Well, the right side is easy. 0 times anything is 0. That worked out fine. Left side. Again, I'm going to rewrite it so we can do the factoring. We can cancel common factors before we go. So before we multiply. This is a fraction, so I'll write 6x as a fraction. So it's 6x times 1 over 3x. Okay, this is the fraction, so I'll write 6x as a fraction over times 5/6. I'm going to move my 0 over. I look like I'm out of space a little bit here. This is the fraction, so I will write 6x as a fraction, so I can multiply it times 2 over x, and of course I know the answer is equal to 0 because 6x times 0 is 0. Okay, so here we have 3x and 6x as a common, take out the common factor of 3x, and I have 2. 6 and 6x, 6 and 6x, take out the common factor of 6, and I have 5x. And x and 6x looks like it's minus 12. Negative 6 times 2. Okay, now I have my linear equation. Let's simplify and combine like terms on the left. 5x minus 10 equals 0. And now let's separate by adding 10 to both sides. And I have 5x is equal to 10, and we think divide by 5. Looks like the answer might be 2. Now we want to note our domain. Our domain said x cannot be 0. Well, we got x of 2, so we're clear there. Okay, we want to check our domain. If we had gotten 0 down here, we would say there's no solution because we can't have a 0 according to our domain, but we have a 2. Let's check it. Okay, so the check. Let's put 2 into the original. So 1 over 3 times 2 plus 5/6 minus 2 over 2. Does that equal 0? 1 over 3 times 2 plus 5 over 6 minus 2 over 2. Does that equal 0? Well, let's see. I can do this probably mentally. This is 1/6. This is 5/6. And this is minus 1. A number divided by itself is 1. Is that 0? Yeah, this is 6/6, which is 1/6 minus 1. Yep, I feel pretty good. The answer is 2. Okay, I feel pretty good about that. Let's do it graphically. Okay, I'm going to, because I want to show you something here. So let's see, graphically. Okay, you want to note here, this equation is already equal to 0. So I'm going to use a function called find the zeros on my calculator. I want to calculate the zeros. So let's do that. Let's just put in to y1 the left side. 1 over 3x plus 5 over 6 minus 2 over x. And we want to calc the 0. Okay, oops, I'm sorry, I got to come up to, there you go, now you can see it. y1 is equal to the left side, which you can see is right here. And because it's equal to 0, I'm going to calc the 0 instead of calculating the intersecting points. Intersecting point, probably. Okay, let's come into here. Okay, let's go to y. Let's clear out my previous. Okay, I got quite a few fractions here. So let's see, 1 over 3x plus 5 over 6 minus 2 over x. I'm going to do my zoom to my standard again, so zoom 6, and here it comes. It's not going to be a straight line. Okay, so there we have it. Okay, so now, because it's equal to 0, I'm going to say calc 0. Because that's what I have here. I want it equal to 0, so I'm going to calc the 0. The 0 is where it hits the x-axis. Those are my zeros. So I need to set left bounds and right bounds. Well, it looks like it crosses right here. So I got to set my left bound. There's on the left side of that intersection. Okay, notice it makes a line. Tell me where the left bound is. Just go to the right side of it. So there's I want to look in between these two x values for that crossing point, for that 0. And then we're going to press enter again. And sure enough, the 0 is at 2, right? Which is what we have right up here. Whoops, let me slide down a touch. Okay, there we have it right here. We have a 0 at 2 right there. Okay, and we knew that. We knew that x could be 2. And the result is 0, which we can see right here, the result is 0. So that's one way to do it. That's probably a quicker way. If you prefer, you can, of course, say, I'll make sure you can see this. You can, of course, say y1 is equal to the left side. y2 is equal to the right side, which in this case is 0. And now you want to calc the intersect. Oops, not interest. How about intersect of the two? But you might want to get used to calc 0 because we're going to see more of that when we get to inequalities, okay, to calculate the zero. So when it's already set equal to 0, like this one is up here, you can just say, hey, I'll just calc the 0 with just one y equation, and then I'll find the 0 where it crosses the x-axis. Okay, last problem. A bit more complicated. Let's take a look. So you want to solve this one. 3a over a minus 1 plus 2 equals 3 over a minus 1. This is a rational expression. I've got two ratios here with polynomials involved. Let's first note the domain, because we're dealing with fractions. We want to note our domain, and we want to say, oh, this one's using the letter A. So it's a set of all a's such that, well, it looks like in both cases, a can be 0. We can have a 0 in the numerator. The problem with fractions is we cannot have a 0 in the denominator. So a, in these two cases, cannot be 1. An a value of 1 results in 0 in each of these denominators, and that does not exist. So the set of all a's such that a does not equal 1. So again, if we solve this and out comes a equals to 1, we have no solutions because a cannot equal 1. Let's see what we get for a solution. Okay, let's see here. Denominators. My denominators are a minus 1 and 1. The denominator under the 2 is a 1. So those are my two denominators. I'll tell you, let's go a minus 1 and 1. Well, that makes it easy. Lowest common denominator is equal to a minus 1. Okay, let's multiply it. So I'm going to rewrite it again. So 3a. I'll tell you, well, let's just multiply both sides. We can shortcut this a little bit. That's a fraction. So I'll write a minus 1 as a fraction over 1. And I'll multiply it by 3a over a minus 1. Same thing to the number 2 here. I need to multiply it by a minus 1. So that's my left side. Multiply both terms, everything on the left, by a minus 1. Right side, again, this is a fraction, so I'll write a minus 1 as a fraction to multiply the right side. Okay, let's see here. Common factor, common factor. So I have a 3a. I can distribute plus 2a minus 2. Common factor equals 3. Excellent. Now let's simplify. We'll have 5a's on the right. Now let's separate. I'll add 2 to both sides. And I have 5a equals 5. And now let's solve. Divide by 5, divide by 5. A is equal to 1. Now a lot of students will say, got it! A is 1, and they're all done. But wait a second. Okay, first off, we need to check our domain, and our domain says A cannot be 1. So this should tell us, okay, A cannot be equal to 1, the domain, so no solution. Okay, we could also check it. If you look here, we put 1 in, and we say something's up. You know, if we were to recheck this algebraically, we would write 3 times 1, which is 3, over 0. Well, 3 over 0 does not exist. Plus 2 equals 3 over 0, which again does not exist. Okay, let's check it graphically, and we'll see. There's no place they touch. Let's see, graphically. I think you can still see my work. I'll come up a little bit. Graphically, well, I'm going to do y1 is equal to the left side, 3a over a minus 1 plus 2. And y2 is equal to the right side, 3 over a minus 1. And let's see if there's no solution, these two should not intersect. I'm betting that's what's going to happen here. Let's see. I'll clear this one out. Okay, so left side is y1, excuse me, is 3x over x minus 1 plus 2. y2, again, is a fraction, 3 over x minus 1. Okay, let's graph these two. There's that one. So there's my first equation, y1. Here comes the second one. Okay, you can kind of see what's happening here. It can't be 1. And so this red line, while it's getting closer and closer and closer, it's never going to touch. And if you go this way or come down, the red line is always to the left of the blue line. It never touches. So we can do a couple things. If you press trace and you enter a 1 for the x value, which we think based upon right up here, it's 1. It doesn't give you a y value. It can't be 1 because it's not allowed. There's no solution to either side, to either of these equations at 1. And you could probably pick, how about 0.999? So 0.9, whoops. We'll notice that in the y1 equation we get 2995. Whoops. And I think I got to find a way to get the y2 equation. Okay. 0.99, whoops, yeah, 0.999. I get negative 3,000. So they are not the same. They never touch one another. So there's your graphical look, and we'll see more of that as we deal with rational functions coming up later. So there you have it. The key, one of the keys I want to point out is the importance of the check. Because we want to point out the importance of recognizing what the domain is, because when we're dealing with fractions, we cannot have a 0 in the denominator.